My name is Mike Cafarella, and I'm really happy to tell you about a new project we've been working on for some time. It's called Declarative Optimization for AI Workloads. Let's jump into it. Oh, there we go. Okay. I don't need to tell you how exciting all these AI models are. Whether it's large language models, visual language models, or these generative image models, there's all sorts of things to be excited about. They're incredible on their own, and for us, we're especially excited about how they might be building blocks for a new generation of exciting software systems. Now, the software system where they've mainly been involved so far is in chat-like experiences, and those are great, but we think we can go beyond that and build a new class of system. These are ones that involve a lot of data processing, as well as a lot of AI elements. We call these semantic analytic applications. And here are just a few of the things that we might be able to do and that fall into that class. These range from really nitty-gritty things like take two databases about the same topic that were invented by two different teams and combine them without any human beings being involved, to really cutting-edge things like query a video collection as easily as you could query a database table, or build a new generation of systems to help you with scientific discovery. These are all things that would be a lot easier to build nowadays that we've tried to build in the past and had a lot of trouble. These models should make all that stuff easier, except for one thing, which is that right now, programming with AI is kind of a drag. We've seen a few talks about this challenge already today. Imagine you have some kind of concrete goal as a programmer. So maybe you're trying to find all the scientific papers in the material science domain that talk about EV batteries. Maybe you're trying to find all the SEC filings from all the US banks in a particular year and look at their footnotes to see if you can find anything about their likely solvency in the next year. Or maybe you want to find a video of the winning touchdown in every single Super Bowl. All of these are questions that would be previously very difficult to answer. Now they're quite reasonable to do with the models that we have at our disposal. The problem is that these are not the only questions that programmer has in mind. The programmer also has to make sure that these are very fast, very cheap, and retain high quality. These are not simply a single chat message going back and forth. Instead, we might be processing hundreds, thousands, millions of data objects. And so things like runtime and cost are really important. At the same time, there's an earthquake every day in the technology used to build these things. So new models come out with new performance characteristics or new quality characteristics. New hardware comes out or new services are deployed, and new methods of building these things are invented all the time. So at the same time that you're trying to build something useful and retain good speed and good cost, the whole infrastructure is shaking under you every single day. And then finally, even that developer is going to have different priorities at different moments in time. When they first start out, maybe it's important to make the thing cheap and cheerful. You don't want to spend too much on an idea that won't work. But when you finally get to customer deployment, maybe you want that thing to be as high quality as possible. So when you're building these systems, there's a million competing concerns in the programmer's head. How can we actually address all these problems? Well, the good news is that we've solved a problem like that before. If we go back 45 years or so, it was likely that if you had a question about the data inside your company, you might write a custom piece of software to do that. You had to be really concerned with correctness and really concerned with performance. But that was a big problem. Of course, human beings were not perfect at that job, but also there was a huge amount of architectural innovation in computing at that time. What people came up with, including lots of people in this room or even on the speaker's agenda today, were declarative queries, meaning the idea that the user, instead of writing a piece of code, would specify a high-level description of what they wanted out of the data set. Then the computer system could think of all the different ways to make that question as fast as possible and as resource-friendly as possible. Okay, let's try, and they did that at a time when computer architecture was changing a ton, offering lots of different opportunities to the system. Let's see if we can do the same thing for artificial intelligence. Okay, so we've built a system that we call Palimpsest. Palimpsest is a Python package. You can download it and program with it in Python in your Jupyter notebook, however you like. And one feature that it offers is a high-level language for specifying a lot of these AI tasks in very little code. It's very succinct and nice to look at. One reason it's succinct is that you're not telling it how to do a lot of things, because behind the scenes, it is hypothesizing, considering, and testing hundreds or even thousands of ways to implement the program that you've described. After it figures all that out, it tries to choose the implementation that is cheapest, fastest, and will deliver the highest quality. If the universe changes, if there's a new model that's trained tomorrow, I'm sure there will be, then when you rerun your program, Palimpsest will make a different decision on your behalf, again, to optimize for those three qualities. Okay, let's consider a really simple version of one of these semantic analytic applications. In this case, we're going to call it multimodal real estate search. So this is not just saying, I want a house under X dollars, although that's part of your question. Instead, we're going to consider a real estate site where we've got access to a lot of textual listings, some realtor or some homeowner typed all that stuff in, as well as a bunch of photographs. And I'm going to have a lot of questions about this enormous data set. Some of them are going to be pretty conventional. After I've collected all those listings, I want to make sure the listing's in my price range. Okay, maybe I have to understand the text in order to do that. I want to make sure that it's a short trip to MIT. And then also, I want to make sure that it's modern and attractive with lots of natural sunlight. Okay, those are questions. I'm not going to trust the text for those, but I might trust the photographs. So in the application we're going to build here, we have a set of operations that are really conventional database style operations. Filter on price, that's pretty straightforward. And then I have some other operations that really are going to exploit AI models. And those kinds of questions would have been very difficult to answer not so long ago. After I've applied all those filters, I'm going to output the results. Okay, so writing that system, which is pretty difficult in conventional methods, it takes about 14 lines of interesting code in our system. Not so much, I'm not going to go through things line by line. This is the part where I show you whether it worked or not. John was joking about this earlier. Running this question, it takes about 90 seconds of compute to run it. So I pressed play before I came up here so that we wouldn't have to stick around for 90 seconds. We're going to find out together whether it actually completed correctly or not. So could we switch the screen to the laptop? Oh, thank goodness. That's fantastic. Okay. So you can see the code here in the upper left-hand corner. Again, this isn't something that we're going to spend a lot of time going through. But what I do want to communicate is that you don't have to be an AI fanatic. I'm an AI fanatic. I'm friends with lots of AI fanatics. You don't have to be one, though, to write this code. There's no model training involved, at least from the user's perspective. There's no data markup involved, again, from the user's perspective. If you're comfortable building a web app or some kind of database application, this code will be familiar to you. Let's jump down to see the results. So here we are. In this case, we took that program of about 14 lines. The system considered, in this case, 10,140 different implementations of that program and tried to estimate which one would deliver the best runtime, cost, and quality. And here we see our results. So here you can see an address on the left-hand side. There's a photograph. Yeah, modern, attractive, I'd say so. This one, yeah, I mean, we'd have to see the internal photographs, but it's plausible. Again, and again. So in this case, we're actually able to, without too much trouble, mix these AI and traditional concerns. Could we switch back to the presentation now, please? Okay. Let me give you a little bit of technical results here. Here you can see three different plots. These are measuring the runtime of our program on the left one, the cost in the middle one, and the quality on the right-hand one. Okay, so x-axis goes left to right in runtime. On the left in the center image, smaller is better. On the right-hand one, bigger is better. The blue bar here represents an implementation of that program done naively with GPT-4. And the three orange bars are three different decision policies from our system. So maybe you wanted something that was as good as possible on cost, as good as possible on quality, and so on. In all cases, we beat the naive GPT-4 plan. Oops. But what's really exciting is that these abstractions that we offer the user, they allow us under the covers to trivially rewrite the program to not just save you time and money, but also to parallelize it. And if you turn on that option, you retain all the cost savings that you see here. So it takes about 1/3 as many dollars sent to the AI model providers, and it can run in about 20 times faster than the naive program. We can show similar results when you do this, not just on this real estate search, but if you do it on document discovery, if you do it on integrating medical databases, there's a range of these data processing tasks where our language makes it a lot easier to implement, and you get lots of runtime and cost benefits. Okay, I want to say thanks to all my collaborators on this project. If you have an AI workload if you are combining these databases, if you're searching for a place to live, let us know or download this code and you can run the demo that I just ran here. Thanks very much.